Hey everybody, how's everybody doing? So I'm going to do a lesson here very quickly on what I call subway science and our mole calculations. Today we're going to be learning on how to convert between mass moles, moles and number of particles, and how to calculate the molar mass of a particular substance. So here we go. So when we look at chemistry, our central pillar is always something that we call the mole, and its units are written as MOL, and that'll be moles. Okay. Uh, I call it subway science because just like our subway system, everything has a central unifying point. So, of course, ours in the city of Toronto is Union Station. The mole here is going to be Union Station. So, if I'm interested in calculating number of particles, and I showed you guys the equations for this, I'll put number of molecules here, for example. And of course, the units for this is going to be molecules. If I want to go from the number of moles of something that I have to the number of molecules, I have to use Avogadro's number. Now, Avogadro's number is denoted by a big N with a subscript A, and that's equal to 6.02 times 10 to the power of 23, and this is molecules per mole. And so if I want to go from moles to molecules, I'm going to multiply. And if I want to go from number of molecules to moles, I'm going to divide. So you can imagine if you are a person standing in the molecule station of this subway system and you want to go to the moles, you're going to take the number of molecules, you're going to divide by Avogadro's number, and then you're going to determine the number of moles there. Of course, if I wanted to go further, I could always go to number of atoms as well. So if I wanted to go to number of atoms, which of course will give us the unit atoms, then what I need to do is I need to multiply the number of molecules I have by the number of atoms in one molecule. And we'll do some examples of these a little bit later. And of course, if I want to go in the other opposite direction, I need to divide these numbers. Of course, we don't have something that we can place a sample on and it gives us the number of moles, or we don't have something that we have that we can place it and something gives us the number of molecules. So we have to use other units that we can use interconvertibly here to help determine all of these figures. And what can we use? Well, we can use a scale or an electronic balance to determine the mass of substance, and the mass unit that we use is the gram. And we can take something and put it on a scale. And once you know the mass of something and what its composition is, what it's made up of, you can actually determine the number of moles of that particular substance you have. Now, there is a conversion here between the mass and the number of moles. So the converting factor here is something that we call the molar mass. And the molar mass of a substance has the units grams per mole, as was discussed in the previous lessons. So it's how much does 1 mole of your particular substance weigh? And so to go towards moles from mass, I would divide by that substance's molar mass. And to go from moles to mass, I would multiply by the molar mass. And this is the start of the subway science. Of course, we will add more as we go through. We have a whole other section for solutions and solubilities, and we have a whole other section for gases. Those are the subsequent units that we may be getting to. So this is what we call subway science, and it's our starting point. So you can very clearly see that if I wanted to go from mass to, let's say, number of atoms, which is like from one end to all the way to the other, it's very easy. I take my mass, I divide it by my molar mass. That produces the number of moles that we have here. And then for moles, I can multiply that number by Avogadro's number. That will produce how many molecules I have. And if I determine the number of atoms in each molecule, I can just multiply that number to produce the number of atoms. And so you can see it's an easy flow chart. It's an easy way to determine this. When I was taking grade 11 chemistry, I would always draw this out on my tests as I was starting the test, so that I had this as a reference for myself. And it's been passed along many, many, many times. Okay, let's talk about the one thing here that is not an actual value right now, and that's the molar mass. So molar masses are easy to calculate. So these masses can be found on the periodic table as average atomic masses, and their units are in grams per mole. Or in other words, how much does 1 mole weigh? So if I had carbon, for example, and I look up on the periodic table the mass of carbon, it weighs, 12.011 grams per mole. If I was looking up hydrogen, for example, and I went over to hydrogen, I would have a molar mass of 1.008 grams per mole. If I was looking up calcium, for example, I would have a molar mass of 40.078 grams per mole. If I was looking up, and this will be the last one I give to you guys, let's say I was looking at fluorine here, well, my fluorine would have a mass of 18.998 grams per mole. So these are just examples, and these are molar masses of atoms. That is, if I had exactly Avogadro's number, so that is 6.02 times 10 to the power of 23 particles, then I would have 1 mole of particles. But, of course, we don't just have individual atoms flying around. We've got compounds and molecules all around us. So how would we determine the molar mass of molecules? I'll give you guys a good example of one. CH4, you guys know this molecule as methane. If I'm interested in determining the molar mass of methane, all I need to do is take my molar masses and just sum them together in terms of the number of atoms I have of each different type. Now, I don't use up to 3 decimal places. Usually I just round to 2 decimal places. It's just fine. And so here's what I would have. I would have 1 carbon atom at 12.01 grams per mole, and I would have 4 atoms of hydrogen at 1.01 grams per mole for each one of those. If I sum these two values together, I end up with 16.05 grams per mole. So if I had this number of particles of methane and I put it on a scale, it would weigh 16.05 grams. Let's try another amount here. Let's say I had calcium fluoride, CaF2. So if I had calcium fluoride and I wanted to know its molar mass, well, calcium has a molar mass of 40.08 grams per mole, and fluorine has a mass of 18.9. Let's round it to 19 there. But I have 2 fluorines at 19.00 grams per mole, and I end up with 78.08 grams per mole. And so that's how you determine the molar mass of these particular substances. So if I had Avogadro's number of calcium fluoride molecules, so if I went out, grabbed some calcium fluoride out of the back room there, and I weighed out exactly 78.08 grams of calcium fluoride, I would have 1 mole of calcium fluoride. So I hope that is clear to you guys. Now there's a practice sheet on the website under day 2, which asks you to do moles and mole calculations. And it's going to be asking you to either determine the molar masses or convert between any of the things that we saw using that particular Subway Science chart. So try it out. There's a lot of questions on there, probably a couple hundred questions. And it's just a matter of getting good at it and practicing a lot, and you'll get it, no problem. I'll see you guys later.